Today, I will introduce the implement of a multisensory concept learning framework based on spiking neural networks with BrainCog. Concept learning, or the ability to recognize commonalities and contrasts across a group of linked events in order to generate structured knowledge, is a crucial component of cognition. Multisensory integration benefits concept learning and plays an important role in semantic processing. For example, when we learn the concept of tea, like here, acoustically, we will perceive the sound of pouring water, the sound of clashing porcelain, the sound of drinking tea. On taste, we can feel the tea is bitter or sweet. In touch, tea is liquid and we can feel its temperature. On smell, we can perceive the various scent. And visually, it often appears with the teapot or tea bowl. And the tea leaves will have different colors. Combining information from multiple senses can produce enhanced perception and learning, faster response times, and improved detection, discrimination, and recognition capabilities. We represented a multisensory concept learning framework based on SNNs with BrainCog. Since there is no biological study to show whether the information of multiple senses is independent or associated before integration, two different paradigms are designed in our framework: the independent merge (RM) and the associated merge (AM). The types of inputs and outputs of the two paradigms are same, but the structure of the SNNs are different. The RM paradigm is founded on the commonly used cognitive psychology assumption that information for each modality of the concept is independent before integration. It is a two-layer spiking neural network model, like here, with 5 neurons corresponding to the stimuli of the concept of 5 separate model information in the first layer, and a neuron reflecting the neural states after multisensory integration in the second layer. We record the spiking trends of the postsynaptic neuron and transfer them into integrated vectors for the concept. While the AM paradigm assumes that the information for each modality of the concept is associated before integration. It is the 5 neural spiking neural networks model, with 5 neurons corresponding to the stimuli of the concept of 5 separate model information. They are connected to one another, and there are no self-connections. We record the spiking trends of all neurons and transfer them into integrated vectors for the concept. The generated representations of both paradigms are closer to human beings than the original ones. And our findings also show that the I'm paradigm performs better at multisensory information for concepts with higher modality exclusivity, while the AM paradigm benefits the concept of uniform model information. And our work is a pioneer work in the field of concept learning with SNNs and provides a solid foundation for modeling harmonic concept learning. And in our BrainCog, in the multisensory integration folder, we will show the source code of our framework. There are 2 files. The main components are the RMNet and AMNet, and the function to calculate the weight, the function to convert the multisensory representations into spiking trains, the function to convert spiking trains into integrated vectors. Here. And finally, we test our model with classical BBSR dataset. Okay, that's all. Thank you. If you find our framework useful in your work, please cite this source.